In this video, we will continue reviewing project analysis using rates of return with a focus on the modified internal rate of return.
Now that we have figured out how to calculate IRR using a series of different tools, let's talk about a return measure that may be more appropriate in corporate finance settings, and that is the modified internal rate of return. MIRR is the calculation of a project's rate of return over time, but assumes that we reinvest at the project's discount rate. That is to say that we're going to now assume that instead of investing at the project's rate of return, we invest at the project's discount rate. So again, given a required initial investment, the MIRR produces an estimate of the discount rate that would set the project's NPV equal to 0, assuming reinvestment at the project's discount rate. MIRR resolves that flawed reinvestment assumption of IRR and also allows for changing cash flow directions over time, but if we're looking at projects of different scale, we may still reach the wrong conclusion if we're comparing projects.
Now let's set up our modified internal rate of return problem. First, the $1,000 cash outflow is already in present value terms, and there are no more cash outflows to discount, so our present value will be negative $1,000. Second, our first year's cash inflow of $450 will be compounded to the end of our project, or 2 periods. 450 times 1.1 squared equals 544.5. So the future value of our first year's cash flow is 544.5. Our second year cash flow of 350 will be compounded for 1 period. 350 times 1.1 equals 385. And our terminal cash flow of $250 is already in future value terms, and it doesn't need to be compounded. We add up those future values, and we arrive at a future value of 1,179.5.
Now we will treat that as a zero coupon bond and solve for the yield to maturity. N equals 3. Present value equals negative 1,000. Payments equal to 0. Future value equal to 1,179.5. And we'll solve for the yield to maturity, 5.6573%. Since the modified internal rate of return is less than the weighted average cost of capital, our decision rule tells us that we will reject this project. Now, to calculate MIRR using Excel, fortunately we have a built-in MIRR function. Again, just like calculating IRR, we will enter or calculate a series of evenly spaced cash flows. The first cash flow, again, will represent the initial cash flow required at the time that we kick the project off. Unlike IRR, our cash flow can change direction over time. They have to be net cash flows, as explained earlier, and then we use the MIRR function. The arguments that we require here are the expected cash flows starting in year 0, the financing rate, which is the weighted average cost of capital, and the reinvestment rate. Now, usually these will be the same, but if a firm believes that it has projects that can reinvest cash flows at a higher rate of return than the weighted average cost of capital, then it can use that higher rate as the reinvestment rate. And we'll typically accept any independent project with a value greater than the required rate of return, often the discount rate or the WACC. While the MIRR decision will usually match the NPV decision, for mutually exclusive projects of equal scale, the decisions may differ for projects with unequal scale. This concludes our review of project analysis and selection using rates of return. We've looked at internal rate of return and modified internal rate of return. We've used financial calculators and spreadsheets to find both.